Hello friends, welcome back to my YouTube channel Maths by Samit Deshmukh. So in this video we are solving question number 6 from Miscellaneous Exercise 2A. In the last video we have solved first 5 example. So if you are new on my channel, subscribe the channel and hit the bell icon to get the notification of every newly uploaded videos. See, in this question number 6, one matrix A is given to us of order 2 by 2 and X is another matrix of order 2 by 2, and this matrices satisfies which condition? A into X is equal to I, means multiplication of this matrix A with this matrix X is identity matrix. It is given to us, and using this condition we have to find out element of matrix X. Okay, so first we have written the given condition. A is one matrix whose elements are 1 2 3 4, and this matrix satisfies which condition? Its multiplication with matrix X is identity. Just we have substituted the value of matrix A, and on this side we have written identity matrix, isn't it? Now to find out our matrix X, we have to convert this matrix into identity. If we are able to convert this matrix into identity, so on this side identity into X will be equals to X, and on this side whatever will be the new matrix we are getting will be the value of X. Now observe here, X is prefactor or post factor? It is post factor, and post factor remains constant in case of row transformation or in case of column transformation? Definitely in case of row transformation. So means we have to solve this example applying row transformation, and using row transformation we have to convert this matrix into identity matrix. So well, let us try to convert this matrix into identity, means its element should be 1 0 0 1. Already we know that how to convert the matrix into identity. This is our first step. So here we will require 1, already 1 is there, means here we will require 0. Here we will require 0, means operation is on R2. What is the element of R2? 3. 3 को 0 बनाना है तो 3 में से 3 subtract करना पड़ेगा, and whenever we are using addition or subtraction we have to use corresponding element of other row. So here we are using corresponding element of R1. तो यहाँ पे 3 लाने के लिए R1 को 3 से ही multiply करना पड़ेगा, and we have to take what? Subtraction. So here also 3, and if we are multiplying here by 3, here we will get 3. 3 minus 3 will become 0. So let us perform this operation here. So since operation is on element of R2, so keep element of R1 as it is. So on this side also keep the element of R1 as it is. So our operation is on R2, we are using corresponding element of R1, we are multiplying to R1 by minus 3. Multiply by minus 3 plus 3 will become 0. Multiply by minus 3 into 2 will be minus 6. Minus 6 plus 4 will be equal to minus 2. Multiply by minus 3, here we will get minus 3 plus 0 will be minus 3. If 0 is there, then R2 does not changes, isn't it? So in this way we have performed this operation on the element of R2. Now here we will require what? Plus 1. Here we will require plus 1, and here we will require 0. तो ये दोनों भी एलिमेंट एक साथ भी मिल सकते हैं हमें. So to get 0 here we have to take addition of R1 and R2, because plus 2 minus 2 will become 0. और यहाँ पे 1 लाने के लिए हमें R2 को minus 2 से डिवाइड करना पड़ेगा. So if we are dividing to minus 2 by minus 2, we will get what? 1. So let us perform these two operations to convert this matrix into identity matrix. So first operation is on element of R1. So R1 plus R2, 1 plus 0 is 1, and plus 2 minus 2 will become 0. Perform the same operation on this side. 1 plus minus 3 will be minus 2, and 0 plus 1 will be equals to 1. So now we are dividing to the element of R2 by minus 2. So these are the element of R2, divide to it by minus 2. So here we will get 0, here we will get 1. So here minus 3 divided by minus 2 will be 3 by 2, and here we will get 1 by 2. So identity into X will be equals to X, and on this side minus 2 1, 3 by 2, 1 by 2. So these are the element of matrix X. अगर आपको फ्रैक्शन पसंद नहीं है तो आपको मैट्रिक्स से हर एक एलिमेंट को हम क्या कर रहे हैं, 2 से डिवाइड कर रहे हैं. एंड इफ वी आर डिवाइडिंग बाय 2 मीन्स वी हैव टू मल्टीप्लाई बाय 2. सो मल्टीप्लाई बाय 2, व्हाट विल गेट हियर, -4. मल्टीप्लाई बाय 2, हियर विल गेट 2. मल्टीप्लाई हियर बाय 2, 2 विल गेट कैंसिल 3. और यहाँ पे अगर 2 से मल्टीप्लाई किया तो हमें क्या बचेगा, 1. मीन्स सिंपली वी आर डिवाइडिंग बाय 2, दैट्स व्हाई वी आर मल्टीप्लाइंग टू ईच एलिमेंट बाय 2. You are able to write your answer in this form also, or you are able to write your answer in this form also. In this way we have got our required matrix X. Now see the question number 7. In this question we have to find out the inverse of a matrix if it exists. Means first we have to check whether inverse exists or not. If it exists, then we have to find out inverse of the matrix. And when we can say that inverse exists, if the matrix is invertible. And when we can say that matrix is invertible, if it is non-singular. When we can say that matrix is non-singular, if the value of determinant is not equal to 0. Means to check whether inverse exists or not, we have to find out determinant of a matrix. So here in the first example, one matrix of order 2 by 2 is given to us, and only the question is to find out inverse of a matrix. Means we have 3 choices. Either we are able to apply row transformation, column transformation, or adjoint method. Because method is not mentioned here, only the question is to find out inverse. Is it clear? So in this case, that is our priority, which method we have to apply. So total 6 examples are there of order 2 by 2. We will solve 2 examples by adjoint method, 2 by row transformation, and 2 by what, column transformation. So let us try to find out inverse of this matrix applying adjoint method. In case of adjoint method, we have seen 5 steps. First step is to find out determinant. So first find out determinant of this matrix. So determinant of A will be equals to, write down all these elements in a determinant, 1, -1, 2, 3. Now let us simplify this determinant. So here this product is 3 minus this product is -2. Minus and minus will become +2, will be equal to 5. Once the value of determinant is known to us, second step is to find out cofactor of all the elements. So cofactor of elements are, so cofactor of the elements are denoted by capital Aij. Means if we are finding cofactor of first element which lies in first row and first column, then we will denote it by A11. And what is its formula? -1 raised to power I plus j, means 1 plus 1, because I is 1, j is 1, into M11. So which is equal to, so then cofactor of second element is denoted by A12. Cofactor of this third element is denoted by A21 because it lies in second row and first column, and cofactor of this last element is denoted by A22 as it lies in second row and second column. Now substitute the values in this formula, that -1 raised to power I plus j means 1 plus 2 into M12. Here -1 raised to power 2 plus 1 into M21. Here what will get, -1 raised to power 2 plus 2 into M22. So which is equal to, so here we can observe that power of -1 is even number, so its value is +1. Here power of -1 is odd number, so its value is -1. Here also odd number, so -1. Here power of -1 is even number, so its value is what, +1. Now remaining part is to find out the value of minor. So minor is nothing but what, determinant. To obtain the element of this determinant, delete first row and first column. Delete first row, first column, what will get, 3. So then here delete first row and second column. First row, second column, so we will get 2. Here delete second row, first column, here we will get -1. And lastly delete second row and second column, here we will get 1. As it stand, in the determinant only one element is there, and if one element is there in the determinant, at that time whatever may be the element, means whatever may be the number, that number will be the value of determinant. So here we will get 3 into 1 will be equal to 3, 2 into -1 is -2, -1 into -1 is +1, and 1 into 1 will be equal to 1. In this way we have got cofactor of all the element. Once the cofactor is known to us, then write down matrix of cofactor. So matrix of cofactor is, means if we are collecting all these cofactor in matrix, then that matrix is called as matrix of cofactor. This is third step. So 3 -2 1 1. So 3 -2, 1, 1 are the cofactor which we have collected in a matrix, which is called as matrix of cofactor. Once the matrix of cofactor is known to us, then fourth step is to find out adjoint of a matrix. And adjoint of a matrix is nothing but what? Matrix of transpose of matrix of cofactor. Matrix of cofactor is known to us. To find out its transpose, just convert row into column. So here we'll get 3 minus 2. Convert second row into second column. In this way, we have got adjoint. This is the fourth step. What is first step? Find determinant. Second step is to find out cofactor of all the element. Then third step is to find out matrix of cofactor, and the fourth step is to find out adjoint. Once the adjoint is known to us, then it implies that A inverse will be equals to, what is the formula to find out A inverse? 1 upon determinant of A into adjoint of A. So which is equals to 1 upon determinant. What is the value of determinant? 5. And element of adjoint 3, 1, minus 2, 1. Now to check whether our answer is right or not, means this answer depends on what? Adjoint. And to check whether the element of this adjoint matrix are correct or not, just check that simply these two elements are interchange or not. Yeah, 1 or 3 interchange हो गए या नहीं check करो. Yes, 1 and 3 are interchange, and check that sign of these two element will get change or not. यहाँ पे -1 है तो यहाँ पे +1 होना चाहिए, यहाँ पे +2 है तो यहाँ पे -2 होना चाहिए. Means all conditions are satisfying. That's why we can say that our answer is what? Correct here. In this way, we have seen how to find out inverse of a matrix applying adjoint method. Again, second example also we will solve applying adjoint method. Now see the second example here. Whatever the matrix is given to us, we have denoted this matrix by A. Now our first step is to find out determinant of this matrix, because we have to check whether inverse exists or not. So whenever we are finding determinant, write down all these elements in a determinant. Now let us simplify this determinant. This product is -3 minus this product is 1. So which is equal to, sorry, this product is -2 and this product is what? 1. So -2 minus 1 will be equal to -3, which is not equals to 0. And if the value of determinant is not equals to 0, we can say that matrix is invertible, means we can say that A inverse exists. Now first part is completed. To check whether inverse exists or not, now let us try to find out inverse of this matrix applying adjoint method. To find out adjoint, we have to find out cofactor of all the element. So already we have written the cofactor formula of cofactor. Remaining part is just to substitute the value. We know that how we have got 1 minus 1, 1 minus 1, 1. Because if the power of -1 is even number, so its value is +1, and if it is odd number, at that time its value is what? -1. Now let us try to find out value of this minor. So to find out minor of element lies in first row and first column, delete first row, first column. What we'll get here? -1. Now delete first row, second column, here we will get 1. Delete second row, first column. Second row, first column, here we will get 1. Lastly, delete second row, second column, here we will get 2. So 1 into -1 is -1, -1 into 1 will be -1, -1 into 1 will be -1, and here we will get 2. Now collect all these cofactors in a matrix. So here we will get -1, -1, -1 and 2. So this is nothing but matrix of cofactor. Once the matrix of cofactor is known to us, taking its transpose, find out adjoint. So convert first row into first column, -1, -1. Convert second row into second column, -1, 2. Now to check whether our answer is correct or not, check that these two element will get interchange or not. Here 2 इधर आना चाहिए, -1 इधर आना चाहिए. So yes, first condition is satisfying. Second condition, ये दो element के sign change होने चाहिए, and we can observe that their sign will get what? Change. Means our answer is correct. Now remaining part is just to substitute the value in this formula to find out our required answer, means A inverse. So what is the formula? 1 upon determinant. What is the value of determinant? -3. Then element of adjoint are -1, -1, -1, 2. So in this way we have got inverse of a matrix. लेकिन अभी कभी कभी क्या होता है कि ये बाहर निगेटिव नंबर अच्छा नहीं लगता, इसलिए हम ये माइनस से सब एलिमेंट को क्या कर सकते हैं? मल्टीप्लाई कर सकते हैं. इफ यू आर राइटिंग दिस आंसर till you will get full marks, but priority should be given to shift this transfer in this matrix. So here what we'll get? 1/3. So I am multiplying by this minus to all the element of this matrix. So if we are multiplying by minus, then sign of every element will get changed, because negative number will become positive and positive will become what? Negative. So what will get? 1, 1, 1, and here we will get minus 2. So in this way we have got inverse of a matrix. Either you are able to write down the answer in this form also or in this form also. Now let us try to find out inverse of this matrix applying row transformation. But before applying row transformation method, we have to check whether the inverse exists or not. And to check whether inverse exists or not, we have to find out determinant. So we are trying to find out determinant of this matrix. So write down all the element in the determinant. So here product of diagonal element is 7 minus product of off diagonal element is 6. 3 into 2 is 6. So 7 minus 6 is 1, which is not equals to 0. Since the value of determinant is not equals to 0, that's why we can say that A inverse exists. And since A inverse exists, now we have to find out inverse of this matrix. So already 2 example we have solved applying adjoint method. So now 3rd and 4th example we will solve applying row transformation. So whenever we are applying row transformation, at that time which condition we are using? A into A inverse is equals to what? Identity matrix. Now substitute the value of matrix A, where element of this matrix are 1, 3, 2, 7. Keep this A inverse as it is. On this side, replace identity matrix by its element 1, 0, 0, 1. Now our aim is to convert this matrix into identity, so that identity into A inverse will be equal to A inverse, and new matrix on this side will be the value of A inverse. Now to convert this matrix into identity means its element should be 1, 0, 0, 1. Already we have seen that this will be our first step. Means in first column, whenever we are using row transformation, at that time our first step is what? Convert the element of first column into 1, 0. Already 1 is there, means we will require 0 here. And since this is the element of second row, means our operation is on what? R2. और कौन सा एलिमेंट है R2 में? 2 में से 2 सब्ट्रैक्ट किया तो ही 0 आएगा. एंड व्हेनेवर वी आर performing addition and subtraction, at that time we have to use corresponding element of any other row. So यहाँ पे R2 पे ऑपरेशन है और दूसरा एक ही रो बचता है R1, means we have to use the corresponding element of what? R1, and we have to multiply to R1 by what? 2, so that 2 minus 2 will become 0. So we are taking subtraction. So let us perform this operation on the element of R2. See what we will get here in R2. So since our operation is on R2, so keep element of R1 as it is, 1, 3, and here 1, 0, keep it as it is. So observe the element of R2 very carefully. We are using corresponding element of R1 and we are multiplying to R1 by minus 2. Multiply by minus 2. 1 into minus 2 is minus 2. Minus 2 plus 2 will become 0. Again multiply by minus 2. Here we will get minus 6. Minus 6 plus 7 will be equal to 1. Multiply by minus 2. Here we will get minus 2. Minus 2 plus 0 will be equal to minus 2. And as it stand, here 0 is there in R1. So this element does not changes, because minus 2 into 0 is what? 0, and 0 plus 1 will become what? 1. So perform the calculation very carefully. So in this way we have completed our first step. Now what is second step? Is to get 1 here, but already we can observe that we have got 1 here. Now last step is to get 0 here. So now remaining part is to get 0 here, and this is the element of R1. So means our operation is on R1, and here we can observe that in R1 3 is there. We have to convert 3 into 0, means we have to subtract 3 from 3. तो हमें करस्पॉन्डिंग एलिमेंट R2 का यूटिलाइज करना पड़ेगा, और R2 पे यहाँ पे 3 चाहिए हमें. सो वी हैव टू मल्टीप्लाई टू R2 by what? 3, because as it stand 1 is there and 1 into 3 will be 3, and later on 3 minus 3 will become what? 0, means we have to take the subtraction here. So let us perform this operation on the element of R2. Let us see what we are getting. Operation is on R1, so keep element of R2 as it is, isn't it? So observe the operation. This operation we are performing on element of R1, and here this operation is on R1 and we are using corresponding element of R2, and we are multiplying to R2 by -3. Multiply by -3, -3 into 0 is 0, 0 plus 1 is 1. Multiply by -3, 1 into -3 is -3, -3 plus 3 is 0. Multiply by -3, here we'll get -3 into -2 is 6, 6 plus 1 is 7. Multiply by -3, so here we'll get 1 into -3 is -3, -3 plus 0 is -3. Now on this side, this matrix will get converted into identity. Identity matrix into A inverse will be equal to A inverse, and on this side, whatever may be the new matrices we have got will be the value of inverse of the given matrix. Now see the example number 4th. In this case also we are trying to find out inverse of this matrix applying a row transformation. So first, to check whether inverse exists or not, find out the determinant. So write down these element in the determinant: 2, -3, 5, 7. So first take the product of diagonal element, that is 14, minus this product is -15, minus, and this minus will become +15. 15 plus 14 will be equal to 29, and here we can observe that value of determinant is not equals to 0, means matrix is invertible. Matrix is invertible means we can say that A inverse exists. So since A inverse exists, to find out the inverse applying row transformation, we have to use which condition? A into A inverse is equal to I. So substitute the value of matrix A, which is nothing but 2, -3, 5, 7. These are the element of this matrix, and element of identity matrix are 1, 0, 0, 1. Now to find out inverse of this inverse, A inverse, we have to convert this matrix into identity, and whenever we are using row transformation, this is our first step to convert the matrix into what? Identity. सबसे पहले यहाँ पे हमें 1 चाहिए. So here we can observe that in R2, what is the element of R2? 5. तो 5 का इस्तेमाल करके ही हमें यहाँ पे 1 लाना है. तो अभी क्या करना पड़ेगा हमें यहाँ पे 6 अगर हम लाते हैं, if we are able to get 6 here, then 6 minus 5 will become what? 1. तो यहाँ पे 6 लाने के लिए R1 को 3 से मल्टीप्लाई करना पड़ेगा, because 3 into 2 will be equal to what? 6. 3 2s are 6, and 6 minus 5 means we are subtracting R2 from it, isn't it? So 3 into R1 means we are multiplying to the element of R1 by 3. This is our second operation of elementary transformation, that we are able to multiply to the element of row or column by non-zero real number, means non-zero scalar, isn't it? So let us perform this operation on the element of R1. So observe the operation very carefully. So because in case in calculation part, if mistake takes place, means our answer will get wrong here, isn't it? So here we are multiplying to R1 by what? 3, and we are subtracting R2 from it. So multiply by 3, 3 into 2 is 6, 6 minus 5 is equal to 1. Then multiply by 3, so here we'll get -9, -9 minus 7 will become -16. On this side, multiply by 3, 3 minus 0 will be equal to 3. So multiply by 3, here we'll get 0, 0 minus 1 will be equal to -1. Now keep the element of R2 as it is, because there is no operation on the element of what? R2. So in this way, here we have got our first required element 1. Now what is second required element here? 0. To complete step first, here we will require 0. So here we will require 0 means our operation is on R2. Adjustant, what is the element of R2? 5. Means from 5 we have to subtract what? 5. And whenever we are using addition subtraction, we have to use corresponding element of other row. Here only 2 rows are there. Here our operation is on R2, means we have to use the corresponding element of R1. और R1 में हमें 5 चाहिए, because 5 minus 5 will become 0. तो यहाँ पे 5 लाने के लिए R1 को 5 से ही मल्टीप्लाई करना पड़ेगा, और क्या करना है हमें? सब्ट्रैक्शन. If we are performing this operation on R2, definitely here we will get what? 0. So our operation is on R2, so keep the element of R1 as it is. On this side also keep the element of R1 as it is. Now our operation is on what? R2. We are using corresponding element of R1 and we are multiplying to R1 by -5. Multiply by -5, -5 into 1 is -5. -5 plus 5 will become 0. Multiply by -5. Minus into minus will become plus, and 16 5s are 80. 80 plus 7 will be equal to 87. Multiply by -5. -5 into 3 is -15. -15 plus 0 is -15. Multiply by -5. -5 into -1 is plus 5. Plus 5 plus 1 will be equal to plus 6, isn't it? Now our aim is to convert this element into what? This element into 1. This is our next step. So second step is to convert this element into 1, because first step is completed. Here we have got 1 0. To convert this element into 1, we are dividing to R2 by what? 87. If we are dividing to 87 by 87, definitely we will get what? 1. So this is our second operation, multiplying or dividing to the element of row or column by non-zero real number. So let us perform the operation on R2. So keep the element of R1 as it is. 1 minus 16, 3 minus 1. So here divided by to R2 by 87. So here we will get 0, here we will get 1. On this side, perform this operation very carefully, because minus 15 and 87, both the numbers are divisible by 3. So minus 15 upon 87 can be written as, if I am dividing to numerator by 3, here we will get 5, and if we are dividing to 87 by 3, we will get 29. Here 6 and 87, we are taking its division, but we are writing this division in simplest form, and we can observe that both the numbers are divisible by what? 3. 3 2s and 3 29s, isn't it? So now lastly, we have to convert this minus 16 into 0, and this minus 16 is the element of R1, means we have to perform our operation on R1. What is the element of R1? Minus 16. So to convert it into 0, we have to add 16, and whenever we are taking addition or subtraction, we have to use the corresponding element of any other row. So second remaining row is what? R2. तो यहाँ पे हमें plus 16 चाहिए, तो हमें 16 से multiply करना है और इनकी क्या करनी पड़ेंगी? Addition, so that minus 16 plus 16 will become 0. After performing this operation on R1, so definitely this matrix will become what? Identity matrix A inverse. Keep it as it is. On this side, perform this operation very carefully on what? R1, because we are using corresponding element of R2, and here if you will observe the element of R2, they are in the fractions. That's why perform this calculation part very carefully. So what is the element of R1 here? 3. And we are multiplying to R2 by what? 16. 16 into minus 5 is minus 80 divided by 29. Take the cross multiplication. 29 into 3 is equals to 87. 87 minus 80 will be equal to 7. 7 upon 29. This difference will be equals to 7 upon 29. Now perform this operation here. So what is the element of R1? Minus 1, and we are multiplying to this R2 by what? 16. 16 2s are 32. 32 upon 29. 29 into minus 1 is minus 29. Minus 29 plus 32 will be equal to 3. 3 upon 29. Keep remaining element as it is, minus 5 upon 29 and 2 upon 29. So on this side, identity into A inverse will be equal to A inverse. Now already we have got the value of, this is nothing but value of A inverse, but if you observe all the element, so we are able to take 1 upon 29 common from all the element, and if we are taking 1 upon 29 common from all element, what we will get here? 7, 3, minus 5, 2. In this way, we have got the inverse of a matrix applying row transformation method. Now, first two example we have solved applying adjoint method. Second two example we have solved applying row transformation, and fifth and sixth example we will solve applying column transformation. So here, to check whether this matrix, inverse of a matrix exists or not, first find out determinant. So here this product 2 into 4 will be equal to 8 minus product of 1 into 7 will be 7. So which is equals to 1, so which is not equals to 0. So that's why we can say that inverse of this matrix exists, A inverse exists. Since we are solving the example applying column transformation, so we have to use which condition? That A inverse into A is equals to identity matrix, because in case of column transformation prefactor remains what? Constant. इसलिए A inverse क्या होना चाहिए? Prefactor. और row transformation A inverse क्या होना चाहिए? Postfactor. Remember, these are the rules to find out inverse of a matrix. So this condition we are applying in case of what? Column transformation. So A inverse, keep it as it is. Write down matrix A where its elements are 2, 1, 7, 4, and on this side write down the element of identity matrix 1, 0, 0, 1. Now our aim is to convert this matrix into identity, and we know that element of identity are 1, 0, 0, 1. What is the first step to convert this element into what? 1, 0. Element of first row should be 1, 0 in case of what? Column transformation. We have to follow these steps. तो यहाँ पे हमें 1 चाहिए. Getting it, first aim is to get 1 here. So here C1 minus C2, if we are performing this operation C1 2 minus 1, so our operation is on what now? Columns, isn't it? So C1 minus C2, let us perform this operation on the element of C1. Let us see what we'll get here. A inverse, keep it as it is. Our operation is on what? C1. So 2 minus 1 will be equal to 1, and here 7 minus 4 will be equal to 3. Keep this element 1, 4 as it is. Perform the same operation on another side also. C1 minus C2. 1 minus 0 is 1, and 0 minus 1 will be equal to minus 1. Here 0, 1, keep it as it is, isn't it? Now here we will require what? 0, because what is first step? To get element of first row or convert element of first row into 1, 0. So 1 already we have got here. Now here we will require 0. तो यहाँ पे 0 चाहिए, तो हमारा ऑपरेशन C2 पे होना चाहिए. And what is that operation? C2 minus C1, 1 minus 1. C2 minus C1. So let us perform this operation on what? C2. A inverse, keep it as it is. Element of first column also keep it as it is. On this side write down 1 minus 1 as it is. So C2 minus C1 means 1 minus 1 is 0, and 4 minus 3 is 1. Here 0 minus 1 is minus 1, and 1 minus minus means plus 1. 1 plus 1 will be equal to 2. So this operation we have performed on the element of C2. Now second step is what? To get 1 here. Already here we can observe that here we have got 1. Now last step, third step is to get 0 here. Means now here we will require 0. So this is the element of first column, means our operation is on first column. And what is the element of the first column? 3. तो 3 में से 3 सब्ट्रैक्ट करना पड़ेगा. तो हमें यहाँ पे 3 चाहिए C2 में, तो C2 को हम 3 से मल्टीप्लाई कर रहे हैं, एंड वी हैव टू टेक व्हाट? सब्ट्रैक्शन. सो हियर A inverse, keep it as it is. After this operation definitely this matrix will get converted into what? Identity matrix. But perform this operation on this side very carefully on C1. So our operation is on C1, and we are using corresponding element of C2. We are multiplying to C2 by minus 3. So multiply by minus 3. Minus 3 into minus 1 is plus 3, 3 plus 1 is 4. Multiply by minus 3 into 2 is minus 6. Minus 6 minus 1 is minus 7. And here minus 1, 2, keep it as it is. On this side here we have got identity matrix. Identity into A inverse will be equal to A inverse. And on this side the new matrix which we have got is the value of inverse of a matrix. In this way we are finding inverse of a matrix applying column transformation method. Now let us try to find out inverse of this matrix applying column transformation. So first let us check what is the value of determinant of this matrix. Already we have written all the element of this matrix in a determinant. So first take the product of diagonal element, that is minus 21 minus this product of minus 10 and 2 is minus 20 minus, and this minus will become plus 20, which is equal to minus 1, means which is not equal to 0. And since the determinant is not equals to 0, we can say that its inverse exists. And since we are applying column transformation method, so we have to use which condition? A inverse into A is equal to identity matrix. So A inverse, keep it as it is. Write down the element of matrix A. On this side write down the element of here write down element of matrix, and on this side identity matrix. Now what is our first step? to convert element of first column, first row into 1 0. Means here we will require 1. So as it stand here, 3 is there. So if we are multiplying to 3 by 3, here we will get 9. And if we are taking its addition with C2, so 9 minus 10 will become what? Minus 1. तो पहले हम minus 1 लाएंगे, and later on if we are multiplying to C1 by minus, then minus into minus will become what? Plus 1. Means first we are trying to get minus 1 here, because easily we are able to get minus 1, and later on we are able to convert that minus 1 into what? Plus 1 also. So here our first operation is on C1, and we are trying to convert C1 into what? First minus 1. So here multiplying to C1 by 3. So what we'll get here? 9. And if we are taking its addition with C2, means 9 minus 10 will be equal to what? Minus 1. So let us perform this operation on C1. So A inverse, keep it as it is. Our operation is on C1. So keep the element of C2 as it is. What are the element of C2? Minus 10, minus 7, and on this side 0, 1. So well, multiply to C1 by 3 and take its addition with C2. Multiply by 3, here we'll get 9. 9 minus 10 will be minus 1. Multiply by 3, here we will get 6. 6 minus 7 will be equal to minus 1. Multiply by 3, here we'll get 3. 3 plus 0 will be equal to 3. Multiply by 3, so here we'll get 0. 0 plus 1 will be equal to what? 1. In this way we have performed this operation on C1. Now now second step is to get 0 here. To get 0 here means our operation should be on what? C2. As it stand in C2, what is the element of C2 here? Minus 10. Minus 10 में क्या ऐड करना पड़ेगा? प्लस 10. तो यहाँ पे अगर हमें प्लस 10 चाहिए तो हमें यहाँ पे माइनस 10 से मल्टीप्लाई करना पड़ेगा. कहाँ पे? C1 को. So we are multiplying to C1 by minus 10. So minus 10 into minus will become what? Plus 10. And plus 10 minus 10 will become 0. So in this way here, this element we are able to convert it into 0, performing this operation. Parallelly, we are multiplying by minus 1 to what? C1. So this element will become what? Plus 1. So our first step will get complete. So A inverse will be equal to, so first let us perform the operation on C1. So here if you are multiplying by minus, so here we will get plus 1, and on this side also if you are multiplying to C1 by minus, here we will get minus 3, here we will get minus 1. Perform this operation very carefully on C2. So this is element of C2. We are using corresponding element of C1 and we are multiplying to C1 by what? Minus 10. चलो यहाँ पे minus 10 से multiply करो, क्या मिलेगा हमें? Minus 10 into minus 1 is plus 10. 10 minus 10 will become 0. So here multiply by minus 10. Minus 1 into minus 10 is plus 10. 10 minus 7 is 3. Multiply here by minus 10. Here we will get minus 30. Minus 30 plus 0 is minus 30. Multiply here by minus 10. We will get minus 10. Minus 10 plus 1 will be equal to minus 9. Now first step is completed. Now here we will require what? 1. So here we will require 1, that is our second step. Means our operation is on second column. And what is the element of second column? 3. If we are dividing to C2 by 3, so here we will get 0 and here we will get what? 1. So let us perform this operation on C2. So A inverse, keep it as it is. So here there is no operation on C1, so keep element of C1 as it is. We are dividing to C2 by what? 3. So here we will get 0 and here we will get 1. On this side also perform the same operation on C2. So these are the element of C2 and we are dividing to C2 by 3. Minus 30 upon 3 is minus 10. Minus 3. So in this way we are dividing to the element of second column by 3. Now lastly here we will require 0, which is our third step. So this is the element of what? C1. And if we are subtracting 1 from 1, means C1 minus C2, definitely this element will become what? 0. So A inverse, keep it as it is. After this operation, this matrix will become identity matrix. Perform the same operation very carefully on this side on C1. So we are subtracting C2 from C1, means C1 minus C2. Minus 3 minus minus means plus 10. Minus 3 plus 10 is 7. Again minus 1 minus minus 3 means plus 3. Minus 1 plus 3 is 2. and on this side minus 10 minus 3 means keep element of second column as it is. So here we have converted this matrix into identity into A inverse will be equal to A inverse, and whatever may be the new matrices we have got on this side will be the required value of A inverse. In this way we have got value of A inverse applying column transformation method. So in this way, from this question number 7, we have solved 2 example by adjoint, 2 example by row transformation, and 2 example by what? Column transformation. Again 4 matrices are there, means again 4 examples are there. If you like the video, please subscribe the channel, like the videos and share these videos with your friends also.